Welcome to SJC content. I am Dr. D. Shobha, Assistant Professor in Department of Physics, St. Joseph College of Arts and Science, Autonomous, Kadalur. In this video, I am going to teach the topic interference. This interference is the phenomenon of light. This is nothing but the superposition of two coherent waves. Coherent wave means coherent source, that is, the waves originate from same source and have same phase difference. That is the coherent wave. In order to take the interference of two waves, the wave should be a coherent wave. Then only we will get the interference. Consider a wave. This is a one wave. It will have the displacement of y1 and another wave. This have the displacement y2. At some time, these two waves superimpose each other like this, or in this way manner also it will superimpose. So two cases are possible. Either the crest of one wave meets the crest of another wave, or crest meet the trough. Crest means this is the crest and this one is trough. Either case is possible. If the wave travel in one direction, at any point the two waves will superimpose. In this first case, the resultant displacement y equal to y1 plus y2. In the second case, y equal to y1 minus y2. Here the displacements are algebraically added. Here the displacements are algebraically subtracted. In this case, we will get the maximum intensity of light waves. Here the intensity of the wave is minimum. So according to this, we have two types of interference. They are types of interference. Number one, constructive interference. Constructive interference. Number two, destructive interference. In constructive interference, we will get the position of maximum. Here we will get the position of minimum. The position of maximum have a maximum intensity and the position of minima has the minimum intensity. When the constructive interference takes place, only the crest of one wave meets the crest of another wave, or trough of one wave meet the trough of another wave. Either case, we will get the constructive interference. Here the displacements are added, so we will get the maximum intensity. Maximum intensity. Whereas the crest of one wave meet the trough of another wave, the displacement, here the positive displacement for the first wave and second wave have the negative displacement. So these two displacements are subtracted, so we will get the minimum intensity. So where the constructive interference takes place, that point will glow. Whereas the destructive interference, the point will be a dark position. This is the brightness we'll get, and this one will give the darkness. We will understand the interference of these two waves in spherical waves. Consider a spherical wave. This is the crest, and the dotted one is the trough. So we have the spherical wave, the another wave. So here we will see, this is the crest meet the crest. Here also we are getting crest meet the crest. Again here trough meet the trough. So these 3 points will have the constructive interference. Whereas this point here, this one is the crest of a second wave. This is the trough of another wave. The crest meet the trough here. So here also, so this is called a destructive interference. So like that the light wave get constructively interfere and destructively interfere. So these point will be bright and this point will be dark. This is about the type of interference we have. Then condition for maxima and minima. For condition for maxima, the path difference between two waves equal to, this is represented by delta, which is equal to m lambda. Here m is the number, it's take the value 1, 2 and so on. Lambda is the wavelength. The path difference is nothing but the difference between the path travelled by the two waves. Consider first wave started from a position S1. The first wave is travelled in this direction. So this is the starting position of the first wave. And another wave S2, it will also travel in this direction. So these two waves have the difference in path that will be travelled. It will be get by drawing a perpendicular line from the first point. We will get the extra path travelled by the second wave. By taking the difference between these two, we will get the path difference. This path difference between the two waves should be equal to m lambda for maxima. Like that, phase difference. Between two waves. This is represented by the another delta. Represented by a delta which is equal to 2m pi. Then condition for minima. In this case, path difference delta equal to 2m plus 1 lambda by 2 and phase difference delta equal to 2m plus 1 into y. This is for condition for minima and this is the condition for maxima. Here the phase difference is the angle difference between the two waves. Angle difference. We have a relation between the phase difference and path difference. Relation between phase and path difference. So, phase difference equal to 2 pi by lambda into path difference. Using this formula, we can get the relation between phase difference and the path difference. Thank you.